Hello, welcome back to our CSCI 430 operating system. And today, I'm going to have actually slides talking about what's the direct or indirect access in the memory. Okay, and before we move on to explain a new chapter, okay, so we need to know what's the basic concept, was the direct or indirect addressing in the computer systems, and then I also give you some sample code, okay, source code, so you can see, try to execute it. It's a C purpose, try to execute, then we can know how the memory addressing using the direct and indirect addressing schemes, okay, and also there's some example demonstrate how this addressing mode that implement in a program. So I already upload it, so you can download and try to execute. Okay, so far for the direct and indirect addressing, you need to know how the memory works in the computer system and getting familiar, okay, with the concept or the pointer. Especially we using a C purpose, right? So the C purpose, how can we using pointers? We're pointing to what the memory location, and you need to able to tell what's the difference between direct and indirect addressing method. So what we may say, the addressing method, we say the direct addressing. Pretty straightforward is the address of the operand, like the data, so to be operate on. So they're explicitly given in the instruction. So if you remember, we talked about the instruction. So all this instruction itself contain the memory location of an operand. So in the early chapters when we talk about the operand and then what's the opcode, right? So we have the PC program counter. Okay, so we have the opcode. Okay, so all this the same thing. And when we have a we call the assembly language, you see that when we need to move, okay, move, let's say A, and then with the scramble with 1,000. So when we actually telling what's the address where the operand is located, then we will tell you. So it's the direct address, okay. So but for the indirect addressing, then we will say, okay, because the instruction provide the address of location where the actual operand is stored, but the operand itself is not directly, okay, referenced by the memory address, but it's the another address. So it's more like it's a pointer. Okay, that means that indirect thing is that we are pointing somewhere, okay, and then from that, the pointed location will access for the actual address, okay, or somehow. So in this case, let's say we move A and then we have the BX, and BX just contains the address of actual operand. And then the processor, okay, first we need access to the value in the BX. That means we need to read it first. When we move to A, then we know, okay, what's the value in the BX. Then we know the get the value of BX, then is the address of the operand actual one. Then we can go to the actual location. So this one is called indirect addressing. So here's the difference between any language, but the one we're using is C purpose. Okay, so they can use to demonstrate all these addressing methods. So that's we're going to use using pointers. And when I give you some source code, just like I give it for rough explanation right here. So this one is called the memory simulation. So we try to use the integer array. So you say when we create is called the memory. So we giving a memory size, right? So this array represent the memory. So where the data they are stored. Okay. And just like initialize it with all the numbers like 0, 10, 20, 30, like this to 90. Okay, so we have 10 items inside this array. Okay, and when we create this one for the direct address functions. So when we really access the direct address function, you see, so we just access which with a direct address location, let's say 3, and then we can directly refer to an element in the memory array, right? So when we retrieve it, so we can get it directly. Then if we want to print it, then we can print it out. So it's called direct address. Okay. But for the indirect address function, so when you look at it, so when we use it, so we use an indirect memory address. So we have variable pointers contain an address. First, let's say we have a case using 4, we need to point to memory 4. And then the program we need to retrieve the value stored at the memory 4. So it's like 40 like this. So we use it to simulating the indirect addressing. Like first we will access the value of the pointer first and to find the actual address. So here's the idea. Okay. Actually, when you look at source code, it's really simple. Okay, straightforward. You will able to know it. So when you read it, then you will see all the output. Let's say what the direct addressing was the memory 3, is the 30 was the indirect is the 4. Okay, it's 40. Okay. You can modify and then make your own version, but when you look at the sample one, then you see it's pretty easy for direct and indirect. And if you want to modify, let's say I want to modify the direct addressing, you can want to change to different value for direct address 7, then you will check the output, and then you will see, okay, what's the value printer, what's the stored memory 7, or if we want to modify indirect address, then we need to change the value of pointer and see how indirect addressing that behave, right? Okay, so when we change the pointer to 2, then the program will point to the value at memory 2. Okay, straightforward. And for some additional way, so if we want to change, I want to do it, let's say larger memory instead of a fixed size. Okay, let's say I have a memory size 10, then I want to expand it to like a larger number, 100 or whatever. So you can do it. Or sometimes we have the called double indirect addressing. Okay, so we will try to extend the program. So to similar double indirect addressing. So let's say the pointer itself point to another pointer, and that pointer points to the actual location. So it's called the double indirect addressing. So you can take a look of it. I'm using the two pointer, let's say pointer 1 and pointer 2. Okay, so like pointer points the pointer 2 and pointer 2 point to the actual memory address. So it's how the viewer will be using is like it's common using in the operating system. Okay, I'm compared to when we need to handle the function pointers, some array pointers. Okay, or sometimes when we are working with the dynamic memories, then we also needing the indirect addressing. So you need to know how we actually like working. And before I switch, I like to show you the address. Change to the source code right here. Right here. And in the beginning, you see the direct addressing. So I'm giving what's the actual the direct address. So it will be 3 right here. Okay, so when we go into access it, just get the value and that's it. And for the indirect addressing, first I need to tell you what's the pointer. Okay, and then what's the pointer, and the pointer pointing to the memory location, and you will see how it looks like. And in the main address, I create some values, right? And even though you see they are like the source code kind of similar, but I changed the name, but because the name is telling is a different way, because at first I need to access to the pointer first, okay, and then telling you. So instead of direct access, I know which element I need to access. This time is like based on pointer. So we need to read the pointer value first. Okay, read the pointer value and then access it. So we need to modify and change it. And sometimes like we also like checking. So if you look in this one, if we need to extend it, then you can change let's say we asking the direct address. So we make sure like is it out of the range, and if it's safe, then we can access it. Okay, so we can read it. If for the indirect addressing, okay, we make sure like the pointer, okay, so is it pointed to a correct range? Okay, if it's correct range, then we will access it. In this part, kind of like skip that is like we need to read the pointer. Okay, in normal operation, we first like we're going to read what's the pointer's value, and then we read the pointer value and then access for the location. But this one just like simulating the most the interesting part is the double indirect addressing. So using the double indirect addressing, so it's more like using a pointer, right? So you say we try to access the address. What's the memory address? First pointer, and then what's the second pointer? We're getting what's the value of the pointer 1, say we pointer 2. So when we try to retrieve it, we need to make sure the pointer to, okay, so what's the value? Make sure it's like, okay, in between the memory size, okay, so, or the starting point of the memory and also the memory size. You know, for the array, there is consecutive like memory location, right? So it's I keep going. So we try to make sure the pointer values are inside. So it's the first, we need to make sure that, okay, is it in between? Okay, pointer to it. And that's why we saving the memory, the array, okay, location. If you know the syntax of C purpose, we can use the pointer, like pointing to the memory starting point and then using +1, okay, to access the next value. That means that every time we can use the +2, +3 to access the next value, right? So because the index start from 0, okay. So here's the idea there's a create. And so far they are pretty simple program and telling what's the simulating the idea. And that's why I say there's a design for it and there's a more additional. So we talk about the array pointer and then how can we access it using the array pointer. Okay, every time we just like using a pointer of it and they save it. There's like which one is pointing to, and then access the address. Um, if we fail, then it will giving error. Okay, so if you're interested, you also can execute this one. Okay, just like output it and then try to execute this one and observe how it looks like. And for all this exercise, just like helping you to have a better understanding of the direct and indirect addressing. That's what we mentioned, like also cover in our lecture of the operating system. And later we will start keep continuous on our lecture. Okay, so this one just a quick revision, and thank you so much.